Hello everybody, I hope you're doing well. So today we are going to talk about z-scores and z-distributions. So it's not exactly the z's that you see here in this picture, but those are nice as well. So what do I mean by this? Well, just as a review, we talked about a normal distribution, and a normal distribution provides information about our data, our shape of our data. Is it comparable to a population distribution? And can we make inferences or educated guesses based on our distribution? And we learned from last week and the week before last about how things can get shifted way off a direction from a normal distribution through either skewness or kurtosis. And sometimes variability can do some things to our data that may not be representative of a normal distribution. And so what we will do today is assume that we have almost a perfect normal distribution and its representation of the population. And now what we're going to do with this is standardize the scores. Well, what is standardization? Let me just say this. When you think of standardization, think of a way of converting something into the same thing. So you convert one score into the same thing, and you convert another score into the same thing. I'll explain in more detail a little bit later. But let's say you and your friend are taking a final exam for your psychology class, and you are taking your final exam at the University of Harvard, and your friend is taking the final exam at Yale. Now, your friend scores a 452, and you score an 84. But as you notice here, these are different scales. This is out of 200 or 750, and your score is out of 100. So how can you compare how well you did compared to your friend? Well, standardizing scores can help us do that. So we see where our score is maybe on a distribution of the data, and assuming we have a normal distribution, your score is like right here at 84, and your friend's score is right around here, I would say, 452. And still, it's a little bit tough to know who did better compared to the average. But we're able to compare these two groups by standardization. Lo and behold, we have standardization here. What happens is when you standardize a distribution, the mean, in this case the mean is 77, and the mean in this case is 400, the mean becomes 0 when you standardize a distribution. And then one standard deviation, which is represented right here, becomes one standard deviation, becomes a 1. Doesn't matter if the one standard deviation difference from the mean is 500, or if it's 83 from 77, you will get a standardized standard deviation of one standard deviation for this one and for this one. And if you move to 2 standard deviations, it'll just be 2. So it's a way to compare multiple different measures of different scales and see how each one relates, maybe see how a data point relates to the mean. And in this case, if we were to compare each participant's score, or your score compared to your friend's score, we would put our answer into this equation, which is the score that you have, 84, minus the mean, which is mu, 77, divided by the standard deviation. And although you cannot see the standard deviation, I listed it right here. What I probably need to do is go ahead and move it right over here just so you can see it. give me a moment here as I move these over just so that you can see it. I think that's just about right. It's a little bit jumbled up, but you get the point here. Is all I'm doing is plugging in these numbers here. So the mu is represented by 77, and the 6 is represented by the standard deviation. And lo and behold, we see that in this case, your score is 1.16 standard deviations away from the mean, which is right about here. And your friend's score is exactly, or almost exactly, 0.52 standard deviations away from the mean. So that's pretty much the take-home message, and that's what we will do today, is we're going to standardize scores and see how far, we're going to standardize distributions, I should say, and see how far a data point is away from the mean. And the way that we will use the length is standard deviation lengths. So let me go ahead and sort of show you this right here, just to sort of rehash what I was saying before. Is you can have measures of different levels and you standardize them, and you're going to get a mean of 0 and a standard deviation of 1, the first standard deviation. So it doesn't matter what your scores are on here. Once you standardize them, they all become the same. They all get their mean to 0 and their standard deviation to 1. Take-home message: standardization, or standardizing a distribution, is taking your raw scores and converting them into z-scores. The shape of your distribution will always stay the same. The mean of a standardized distribution is always 0. This is our mean, and we make it into a 0. Now, going back to this example right here, I'm going to go ahead and copy this so that you can see the standard deviation here. The standard deviation, you know, if you do 77 plus 6, you're going to get 83. The first standard deviation, which is 83, is going to just be 1 standard deviation. The second one is going to be 2 standard deviations, and so on. You'll always change to 1, and then 2, and then 3, denoting how far away you are from the mean. The distribution shape will not change. So the distribution will not change, and that includes the shape. So skewness and kurtosis, those things will not change. And so we're going to see this a little bit later on. But just know these principles right here. And really, if we were to go into your walkthrough, the walkthrough has this information about this. So if I was to just move this over, here is your walkthrough, and you can probably get a review from chapter 5 on z-scores. But all the information you have, including we're going to do an American Psychological Association write-up of z-scores and our frequencies. Before we get into z-scores, we're going to do our frequencies and percentages and so on, just to give you more practice on that, because this is going to be something that's going to be reoccurring later on when we're doing other things. Okay, so I think that's my soapbox for this section. We're going to jump into the data, and what I'm going to do is we're going to go into a data set that is very similar to our data set. It's going to be called not homework because it's not your data set. It is almost the same, but I switched some things around because I don't want to just provide the answers. I want to have you get used to the process of making these calculations and figuring out SPSS and those interpretations and so on. So thank you so much for listening, and I will talk to you soon.